Let's imagine that this bar here represents some ordered numerical data. The value on the left will be the lowest value, and the one on the right will be the greatest value. If we then split this data into 4 equal-sized sections like this, the one in the middle will be the median. The one 1/4 of the way through the data is known as the lower quartile, and the one 3/4 of the way through is the upper quartile. You should remember all of this from GCSE Maths. Instead of writing the lower quartile, we sometimes write Q1 for short. We can write Q2 for the median, and Q3 for the upper quartile. Each of these values locates a particular point within the data, so we call them measures of location. Using this diagram, we can also look at some other measures. If we do the difference between the greatest and lowest value, we call this the range. So to calculate the range, you do the greatest value, subtract the lowest value. We also have the difference between the upper and lower quartiles. We call this the interquartile range. So to calculate the interquartile range, we do Q3, the upper quartile, subtract Q1, the lower quartile. These are not measures of location, but instead measures of spread. They give an idea of how spread out or varied the data is. Since each of these blocks represents 1/4 of the data, we know there's 25% of the data between the lowest value and the lower quartile. There's also 25% between the lower quartile and the median, and between the median and the upper quartile and the greatest value. We can use this information to say things like, there's 50% of the data between the upper and lower quartiles, or there's 75% of the data between the lowest value and the upper quartile. You need to be able to work out the quartiles and the median in various different situations. This is actually an area of contention as there's many different ways of doing it, and they're slightly different and there's no agreed one way that we always do this. The way I'm going to suggest to you is the way Edexcel describes to do this in their teaching guidance. Let's begin by looking at how we can locate the lower quartile. We're going to imagine we have a list of n numbers. The first thing we do is work out n over 4, and there are two possibilities. If n over 4 is an integer, we add 0.5 and this will locate Q1. Of course, n over 4 might not be an integer, and if n over 4 is not an integer, we round up and we locate Q1 this way. This will become more clear if we do an example. So let's imagine n was 20, which meant we had 20 numbers in our list. We divide this by 4, which will give you 5. Then we need to decide if this is an integer or not, and 5 is an integer. If it's an integer, we add 0.5 to it, so add 0.5 to 5, which will give you 5.5. This will tell you that Q1 will be in position 5.5 in your list. Let's have a look at a second example. So n is 37. We do 37 divided by 4, which is 9.25. This time it's not an integer, and in this case we round up. So if you round 9.25 up, you end up at 10. So Q1 will be in the 10th position this time. This might seem slightly odd because if you rounded 9.25 to the nearest integer, you'd actually round down to 9. But in these examples, we always round up to the nearest integer. Now if we move on to the median, well, it's exactly the same process, but we switch the n over 4 for n over 2, and this will locate the median. For example, if n was 28, we do 28 divided by 2, which is 14. 14 is an integer, so we must add the 0.5. So the position of the median will be 14.5. If n was 9, we do 9 over 2, which is 4.5. This time it's not an integer, which means we round up. And if we round 4.5 up, we end up at 5. So in this example, the median would be in the 5th position. Now to do the upper quartile, we do the same once again, but we change the formula for 3n over 4. You can think of this as 3/4 of n. Here's some examples. So if n was 48, we do 3/4 of 48, and this will give you 36. This is an integer, so we add the 0.5, which gives you 36.5. So that's the position of Q3, the upper quartile. And if n was 13, we do 3/4 of 13, which will be 9.75. This is not an integer, so we round up. If you round 9.75 up, you end up at 10. So in this one, Q3, the upper quartile, would be in the 10th position. Let's have a look at this with a real example. So here's some data. If we count up all of the data items, we can see that n is 11, because there are 11 of them. So we'll start with the lower quartile. We divide n by 4, so 11 over 4, which is 2.75. That's not an integer, so we round up to 3. So Q1, the lower quartile, is in the third position. We can now just count along the list to the third number, which is this one here. So Q1, the lower quartile, is 8. For the median, we do n over 2, so 11 over 2, which is 5.5. Not an integer again, so we round up to 6. So Q2, the median, is in the 6th position. That's this number here, 17. So Q2 is 17. And finally, for Q3, the upper quartile, we do 3/4 of n, and this is 8.25. Once again, not an integer, so we round up to 9. So Q3, the upper quartile, will be in the 9th position. If you count through 9 numbers in the list, you end up at 28. So the upper quartile is 28. Let's do another example like this. So this time we have a much larger list. If you count up all of these, there are 28 numbers. So for the lower quartile, we do 28 divided by 4. This gives you 7, which is an integer, so we add that 0.5 to get 7.5. So Q1 will be in the 7.5th position. That's the number that's halfway in between the 7th and the 8th number. The 7th and 8th numbers are 9 and 13, and halfway in between those is 11, so Q1 is 11. Now for Q2, the median, we divide 28 by 2, which is 14. This is an integer, so we add 0.5, and we can locate it in the 14.5th position. That's halfway in between the 14th and 15th numbers, which are 19 and 20. Halfway in between 19 and 20 is 19.5, so the median is 19.5. And finally, the upper quartile, that's 3/4 of n, and this comes out at 21. Also an integer, so we add that 0.5 to get 21.5. This tells you the position of the upper quartile. The 21st and 22nd numbers are 31 and 36, so we need to find the number halfway in between these. To do that, you can add them together and divide it by 2. If you add 31 and 36 and divide your answer by 2, you end up at 33.5. So that would be the value of the upper quartile. So we've managed to work out these measures of location. The question could say though, work out the range, which is a measure of spread. Remember, the range was the greatest value subtract the lowest value. For this list, the lowest is 1 and the greatest is 45. So we do 45 subtract 1, which is 44. We could also work out the interquartile range, which is the upper quartile, Q3, subtract the lower quartile, Q1. For this list, the upper quartile was 33.5 and the lower quartile was 11. So the interquartile range will be 33.5 subtract 11, which gives you 22.5. You also need to be able to work out the measures of location if the data is presented in a frequency table like this one here. So this one shows the number of pets along with the frequencies. To do this, we're going to work out the position of each of the quartiles and the median in the same way we did before. To do this, we need to know the value of n. We can work out n by adding up the frequency column. If we add these together, we get 33. So to work out the position of the lower quartile, we divide 33 by 4, which gives you 8.25. This number is not an integer, so we round it up to 9. So the position of the lower quartile will be the 9th position. Then we divide 33 by 2 instead, which gives you 16.5. Also not an integer, so we round this up to 17. So the position of the median is the 17th one. And then we do 3/4 of this, which gives you 24.75. This is also not an integer, so we round it up to 25. So the position of the upper quartile is the 25th position. So we now know the positions where we can find each of these measures. We just need to find them. One way of doing this is to add an extra column for the cumulative frequency. To complete this column, we take the first frequency, which is 9, and then we just add on each of the next frequencies. So add on 10 to get 19, add on 5 to this to get 24, another 5, so 29, 3 more, so 32, and then 1 more, 33. And that makes sense because n was 33. Now we just look down this cumulative frequency column until we find each of the positions for our measures. So we're first of all looking for the 9th position, and if we go down the first group, we actually hit the 9th number, which means the lower quartile must be in this group. We then look across and see this corresponds to 0 pets. So the lower quartile for the number of pets will be 0 pets. Next, we're looking for the 17th position, and if we go down to the next group, we get to the 19th number, which means we must have gone past the 17th number. So the 17th number is in this group, which corresponds to 1 pet. So the median is 1 pet. Now we're looking for the 25th position. If we go down to the next group, we don't quite get there. We only get to the 24th number. So we go into the next group, which goes to 29, and that means the 25th position must be in this group, which is 3 pets. So the upper quartile is 3 pets. Take this data here, which is Year 10 and Year 11 test scores in percentages. We could be asked to make a comparison between the test scores of students in Year 10 and Year 11. When we're asked to make a comparison, we typically compare a measure of central tendency and a measure of spread. So if we think about our measures of central tendency from before, we have the mode, the median, and the mean. For these lists, there's actually no mode, so the mode is fairly useless. You may remember from the previous video that the mean is affected by extreme values, and this 11% here stands out as a value that's very different to all of the other ones. So the mean might not be the best measure of central tendency to use here. So let's use the median for our comparison of central tendencies. Then we also want to compare a measure of spread, and we've talked about 2 in this video, the range and the interquartile range. Since the range is the difference between the greatest and the lowest values, this would also use that 11% again. So the range is also affected by these extreme values, whereas the interquartile range will not be. So let's first of all work out the median for both of these lists. I'm not going to go through the whole calculation again, but the median for these lists will be in between the 5th and 6th positions. So for Year 10 it will be in between these two, so the median is 76%, and for Year 11 the median's between these two, so 79%. So if we're going to make a comparison of these, we could first of all state that Year 11 had a higher median score. And then what does this actually mean? Well, since this is a measure of central tendency, or an average, we could say that this tells us they did better on the test on average. It doesn't mean that every single Year 11 student did better than every single Year 10 student, but the average student in Year 11 did better than the average student in Year 10. Now for the interquartile ranges. Once again, I'm not going to repeat the whole calculation, but to get the interquartile range for Year 10, we would look at this one, the lower quartile, and this one, the upper quartile, and subtract them. If we subtracted these, we get 13%. If we do the same idea for Year 11, and subtract the lower quartile from the upper quartile, we end up with 18%. So when comparing the interquartile ranges, we could say that Year 11 had a higher interquartile range. And then what does this mean? Well, this means that their test scores were, and then we have a few options of how we say this. We could say they were more varied. So a higher interquartile range means more variation. Or we could say that they were more spread out. Or another phrase that some people use is less consistent. So this is how we use measures of central tendency and location to make comparisons between datasets. Now, if your exam board is AQA, if you could do me a huge favour and leave a comment and like the video, because this is where you leave us. The remainder of this video is not examinable on your course. You're welcome to stick around if you want to, but you're not required to know what we're going to do next. You also need to be able to work out these measures of location from a group frequency table, like this one here. Now, when we have data that's been grouped together like this, or when n is a particularly large number, we change our approach ever so slightly. Instead, we work out the values of n over 4, n over 2, 3n over 4 just like before, but we don't do any adding of 0.5 or rounding up. We just leave them as the value that these calculations give. So for this one, let's work out the value of n, and if we add up all of these, we get 240. Then we do n over 4, 240 over 4, which gives you 60. So the lower quartile is in the 60th position. We don't add 0.5 because it's an integer. Then for n over 2, we end up with 120, so the median is in the 120th position. We didn't need to add 0.5 even though n was an integer. And then for the upper quartile, we do 3/4 of n, which is 180, so it's in the 180th position. Now let's try and work out where these positions are. We'll start with the lower quartile. Just like with the ungrouped table, we're going to add a cumulative frequency column. For this one, I'll just fill in the cumulative frequencies for you. So we look down the cumulative frequency column until we find the 60th position. The first group goes up to the 52nd position, so it's not in there, but the next group goes past 60 to 68, so it is in this one. So previously we would just look across here and say that the lower quartile is somewhere in this interval, between 20 and 40. But you need to actually do better than that. We can try and pinpoint where in this interval it might be. We'll use the following approach. This interval goes between 20 and 40 seconds. And if we think about the frequencies, the previous interval finished at the 52nd number, and this interval goes all the way to the 68th number. If we subtract these, we find the difference between them is 16. So this means there are 16 bits of data in this interval, and that makes sense because its frequency is 16. What we then do is imagine that all 16 of these numbers are distributed evenly throughout the group. We could say that they are uniformly distributed. It would look something like this, with each of the numbers written on. Now we can see where the 60th number is, and for this interval it's actually right in the middle. So if we were to make a sensible estimate for where the time was, we would estimate that it's right in the middle of 20 and 40, which would be 30. So we could say that a sensible estimate for the lower quartile here is 30 seconds. That's certainly better than just saying it's in the interval 20 to 40. The technique that we've used here is known as linear interpolation. This is where we assume that each of the data items is uniformly distributed within the interval. It's important that you understand that this is only an estimate. We're not saying this is definitely the lower quartile, but it is certainly a sensible approach. Let's use this approach to work out an estimate for the median and the upper quartile as well. So previously we calculated that the median would be in the 120th position. So let's get looking down that cumulative frequency column until we find 120. It's not here, it's not here, but for this group we would pass the 120th position, so it's in this interval here somewhere. So let's draw out the interval from 40 to 60. Then we want to consider the frequencies. The previous interval finished at the 68th number, and our interval finishes at the 198th number. And the number we're looking for is the 120th one. Now this time it's not right in the middle, it will actually be slightly to the left of the centre. We'll work out the difference between the two cumulative frequencies here, which will tell us how many numbers are in the interval, and for this one it's 130. Then we want to consider how far the 120th value is through this interval. We can do that by doing the difference between 120 and 68, and this gives you 52. We then consider the same sort of values, but rather than for the frequencies, but for the time. So the difference between each ends of the interval in terms of time would be 60 subtract 40, which is 20 seconds. What we want to work out is this distance here in terms of time. We don't know that, so we're going to call it x. Now because of the way we've drawn this diagram, the 120th value should be the same proportion through the group in terms of frequencies as it is in terms of time. This means we can divide 52 by 130, and we should get the same answer as if we divided this x value by 20. So we can create this equation here. To solve this equation, you just multiply both sides by 20. So we end up with 52 over 130 multiplied by 20, and this will give us the value of x. If you type this into your calculator, you find that x is equal to 8. So we can replace x with 8 on our diagram. This means the 120th value is 8 seconds through this interval, and this interval starts at 40. So we can find this value in terms of time by doing 40 plus 8, which is 48 seconds. So our estimate for the median using linear interpolation is 48 seconds. Let's do the same process for the upper quartile. This was in position 180. So we look down the cumulative frequency column, it's not here, but actually once again it's in this same interval, between 40 and 60. So we draw out this interval once again between 40 and 60, and this one still goes from the 68th number to the 198th number, but the one we're looking for this time is the 180th position. Now this is going to be much closer to the end of the interval, nearer to the 198th. We then follow the same process as before. The difference between these two cumulative frequencies here is 130 again. But the difference between the 180th and 68th position is 112. Then we do the same idea for the times. Well, the difference between 60 and 40 is still 20, and the value we're interested in is the difference here, which we'll call x. We then form the equation by saying that 112 divided by 130 must give us the same value as x divided by 20. To solve this equation, we multiply both sides by 20, and if you type this into the calculator, you find the value of x to be 17.23. We can now replace x with 17.23, and we can consider what this value here is. This is 17.23 seconds through the interval, which starts at 40. So if we add 17.23 to 40, we end up with 57.23 seconds. And that's our estimate to the upper quartile. Let's try a second example of linear interpolation. At any point during this video, you're welcome to pause and give it a try yourself and see if you get the same answer. So for this one, we've been told the table shows the masses of 540 potatoes, and here's the information. And we've been asked to work out the lower quartile, the median, and the upper quartile. So let's first of all work out their positions. There are 540 potatoes, so this is the value of n. So we do 540 divided by 4 for the lower quartile, and this is the 135th position. Then for the median, we divide 540 by 2, and this will be the 270th position. And for the upper quartile, we do 3/4 of 540, which gives you 405, so it's the 405th position. So now we know all of their positions, let's try and locate them within this data. To do this, we need to add a cumulative frequency column. Then we look down this column until we find the 135th value. So we can see that this one will be in the second group here, the interval between 100 and 150 grams. So let's draw out that interval, between 100 and 150 grams. Now we need to mark on the frequencies on the top. This interval starts at the 38th item, and it finishes at the 152nd. We're looking for the one in the 135th position, which will be quite close to the right-hand side. Then we work out the difference between these two numbers, which is 152 minus 38, which is 114, and also the difference between these, which is 135 minus 38, which is 97. Then we do the same with the masses, so the difference between 100 and 150 grams is just 50 grams, and then there's this value here which we're going to label as x. We can then write that x over 50 is equal to 97 over 114. We can solve this equation by multiplying both sides by 50, and that will give you an x value of 42.54. So we now know that x is 42.54. This will allow us to work out this value here. To do this, we can just add 42.54 to the start of the interval, which was 100 grams, and this will give you 142.54 grams. So our estimate for the lower quartile is 142.54. Now let's do the median. So we're looking for the 270th position, that'll be in this group here. So the interval this time is between 150 and 180 grams. Now we need to mark on the frequencies. The previous group finished at 152, and this one finishes at 403. We're looking for position 270, which will be somewhere near to the middle actually. Then we work out the difference between these two, which will be 403 subtract 152, which is 251, and the difference between these two, which is 270 subtract 152, which gives you 118. Then if we do the same for the masses, 180 subtract 150 is 30, and then we label on this value here for x. Then we can write the equation, x over 30 is equal to 118 over 251. If you multiply both sides by 30, you find the value of x to be 14.10. So let's add 14.10 to the diagram, and now we can work out this value here by adding 14.10 onto 150, which will be 164.10. So we found our estimate of the median is 164.10 grams. And finally, onto the upper quartile, we're looking for the 405th position, which will be in this group. So the interval between 180 and 240 grams. The previous interval finished at the position 403, and this one finishes at 518. We're looking for position 405, which will be very close to the left-hand side of this interval. Then we work out the difference between these values, which comes out at 115, and the difference between these values, which is just 2. The difference between the masses here is 240 subtract 180, which is 60, and then we mark on x here. We then set up the equation, x over 60 is equal to 2 over 115. We multiply both sides by 60, and this gives x to be 1.04. So we can add this onto our diagram. Now to find this value here, we just add 1.04 to 180, which is 181.04. So that would be the estimate for the upper quartile. And that's the question complete. Now I'm going to show you just one more question like this, because there's something you need to watch out for in this one. So for this question, we have the daily temperatures to the nearest degree C, which were recorded for 1 year. And here's the information. In this question, we're just going to work out Q3, the upper quartile. So we'll add on a cumulative frequency column and fill those in, and then we'll work out the position of Q3. So there are 365 days here, so we do 3/4 of 365 days for the upper quartile, which will give you 273.75. Now you might be tempted to round this to the nearest position. After all, we can't actually have a number in the 273.75th position. That doesn't necessarily make sense. But you should not round this number. When we use linear interpolation, we leave the numbers as they are. So this is the position we're going to look for, even though it isn't a position of an actual data point. Then we proceed as normal, so we look down the cumulative frequency and realize it should be in this group here. This is the temperatures between 11 and 20 degrees C. So when we come to write out this interval, you might think we would write 11 and 20. However, these temperatures are recorded to the nearest degree. So when we look at this interval here, it's actually any temperatures between 10.5 and 20.5 degrees. So these should be the numbers that we use for our interval. It goes from 10.5 to 20.5. And that's the thing you need to watch out for. The rest of the question proceeds as normal. So the end of the previous interval was frequency 164, and the end of this interval is 281. We mark on our point, which is position 273.75, including that 0.75. And then we just do as we did before. The difference between these two values, the difference between these two values, the difference between the temperatures here, and then we mark on this value that we want to find as x. We then set up the equation, x over 10 is equal to 109.75 over 117. Multiply both sides by 10 and you'll find this is the value of x. So we pop x onto our diagram, and then we work out this value here by adding 9.38 to the 10.5, which gives you 19.88, which would be the answer to the question. So if you ever have intervals that are presented in this way, you must make sure that you use the correct upper and lower bound. Now let's talk about something different. Imagine we had this line of data again, and previously we split it into 4 sections, but this time we're going to split it into 100 different sections. Since we've used the number 100 here, it might not be surprising to know that each of these is a percentile. This one here would be the 10th percentile, which we could write short as P10. This one would be the 38th percentile, or P38, and this one will be the 97th percentile, or P97. We use P for percentile and Q for quartile. If we take a look at the 38th percentile here, we could say that 38% of the data lies below this value, and 62% of the data lies above it. We can also calculate ranges using the percentiles. If we take this percentile here, P30, and this one here, P70, we can work out the range in between them. We call this an interpercentile range rather than an interquartile range. Since we could do the interpercentile range between any 2 percentiles, we need to specify which one we've done. So this one will be called the 30th to 70th interpercentile range. One that is often used is the difference between P10 and P90. So this one will be called the 10th to 90th interpercentile range. All of these interpercentile ranges are also measures of spread. This one is useful because it makes use of 80% of the data still, whereas the interquartile range only uses 50%. It's also unlikely to be affected by extreme values. This is because 10% of the data is missed off at each end, so if there are extreme values, they're unlikely to have any effect. We need to be able to calculate the percentiles in the same way we calculated the quartiles, from a group frequency table like this one here. Let's have a look at how we do this. So for this one, we're going to work out the 29th percentile P29. We need to add a cumulative frequency column on, just like before, and then we need to determine the location of P29. To find the location of a percentile, you just find the corresponding percentage of the value of n. So we want P29, so we find 29% of n. We can see from the cumulative frequency column that n is 80, so we need to find 29% of 80. So we do 29 over 100 multiplied by 80, which gives you position 23.2. And just like in the previous example, we're not going to round that, so we're going to look for position 23.2. We can see from the cumulative frequencies that'll be in the second group. So we draw out the interval between 5 and 6 meters. then the rest of the process is much the same as before. The previous group finished at the 12th value, and this one at the 26th. Then we mark on the point we're looking for, which is position 23.2, and then we just compute the values. So the difference between these ones is 14, the difference between these two is 11.2, the difference between these is just 1, and then we mark on x. We then set up the equation, so x over 1 is 11.2 over 14. Well, this one we just multiply both sides by 1, which actually gives you the value of 0.8. So x is 0.8. So, to find this value here, we just add 0.8 to 5, and we get 5.8 meters. So P29 is 5.8, and that's the answer to the question. Let's also work out the 10th to 90th interpercentile range. So for this, we're going to work out two different percentiles, P10 and P90. We'll start with P10. To find the location of P10, we find 10% of 80. So 10 over 100 multiplied by 80, which will give you 8. So we're looking for position 8. For the position for P90, we do 90% of n, so 90 over 100 multiplied by 80, which is position 72. So we now know the positions we're after. Position 8 will be in the first group, so between 4 and 5. So we draw out that interval between 4 and 5. And this one's interesting because we haven't had to look in the first interval before. When we look in the first interval, the frequency needs to start at 0 and not 1. And this interval ends with a 12th value. This is because we know there are 12 values in this interval, and when we do the 12 take away 0, we want to end up with 12, and 12 take away 1 would be 11, which would suggest there are 11 values in this interval, but that's not true. So if you end up with the first interval, make sure you start that frequency at 0. Then we mark on the value we're looking for, which is position 8. Then we just do as before. The difference between these is 12 take 0, which is 12. The difference between these is 8 take 0, which is 8. The difference here is 5 take 4, which is just 1, and then we mark on the value for x. When we set up the equation, x over 1 equals 8 over 12, and we solve this to get an x value of 0.67 if we round it off. So that's the value of x, and we can find the value we're after by adding 4 and 0.67, which is 4.67 meters. So we found P10 at 4.67 meters. Let's now go and find P90. This is in position 72, which will be in the final group, so between 7 and 7.5. The previous group finished at position 70, and this one finishes at 80. We mark on position 72, the one we're looking for, which will be closer to the 70 end. Then we mark on these differences. Between 80 and 70 is 10. Between 72 and 70 is just 2. Between 7 and 7.5 is 0.5. And we mark on x. Then we set up the equation x over 0.5 is equal to 2 over 10. Multiply both sides by 0.5 and we find that x is 0.1. So if x is 0.1, we can find the value by adding 0.127, which is 7.1 meters. So we found P90, it's 7.1 meters. Now to find the interpercentile range, we simply need to subtract these values. So P90 subtract P10, which is 7.1 subtract 4.67, which is 2.43 meters, and the answer to the question. Thank you for watching this video. I hope you found it useful. Check out the one I think you should watch next, subscribe so you don't miss out on future videos, and why not go and try the exam questions I've linked in this video's description.